Hey guys, welcome to this video. In today's video we will solve some problems of July long challenge 2022, and here are the list of problems we will solve in today's video. So let's start the problem number 1, which is bidding. The first problem is saying that the first problem statement is saying that Elias, Bob and Charlie are bidding for an artifact in an auction. Elias bids A rupees, Bob bids B rupees and Charlie bids C rupees, and all the three numbers A, B, C and are distinct, and according to the rules of the auction, the person who bids the highest amount will win the auction, and we have to determine who will win the auction. And the input format is, the first line contains single integer t, which is the number of test cases, and the next t lines consist of three integers A, B and C, the amount bidden by the Elias, Bob and Charlie. So we have to output the name of the person who will win the bidding round. So this is quite easy. We have to output first compare all these three values, and if A is greatest, output Elias; if B is greatest, output Bob; if C is greatest, output Charlie. In the first one, C is greatest one, so the answer is Charlie. In the second one, B is greatest, so the answer is Bob, and vice versa. Okay, let's move to the second problem, which is pass the exam. And the statement is saying that Chef appeared for an exam consisting of 3 sections, and each section is worth 100 marks. Chef scored A marks in section 1, B marks in section 2, C marks in section 3, and here are the two criteria to pass the examination. The first one is total score of Chef must be greater than or equals to 100, and the second one is sectional cutoff, which is score of each section must be greater than or equals to 10, and we have to determine whether Chef passed the examination or not. And this is the input format: single integer t, which is number of test case, and each test case consists of three space separated numbers A, B and C, which are the scores of Chef in both the three subjects. And the output format is, we have to output either pass or fail, depending on the two conditions which are mentioned here. This is also easy one. Okay, the first one, 900 and 100. Okay, A is 9, B is 100 and C is also 100. So sum all these three values. The sum is 209. Is it greater than or equals to 100? True. And check if A is greater than equals to 10, B is greater than equals to 10, or C is greater than equals to 10. In this case, this is true. Sorry, this is not true. A is 9, B is true and C is also true. But if any one and apply the AND operation, okay, apply the AND operation. Here this will become false and this is true. The value is 1 and A is less than 10, so this will become 0, 0 and 1, 0, 0 and 1, 0, this will become 0, so the final answer will become 0. So in this case we will print fail, otherwise you will print pass. So okay, hope you guys understand this. Okay, the third problem is Chef and Candies, and the statement is saying that there are n children and Chef wants to give them one candy each. Chef already have X candies with him. To buy the rest, he visits a candy shop. In the shop, packets containing exactly 4 candies are available, and determine the minimum number of candies packets Chef must buy so that he is able to give one candy to each of the n children. And the input format is T, denoting the test case, and each case consists of single integer n, which is total number of children, and X, the number of candies the Chef initially have. and we have to output the minimum number of candies packets chef must buy if he is able to give one candy to each of the n children. So let's copy the input. Okay, this is the first one. Here n is 20 and x is 12. So there are 20 children and 12 chocolates. So let's find remaining children equals to 20 minus n minus x, which is 8, and each box of chocolate consists of 4 chocolates. Each package consists of 4 candies. So chef needs to buy 2 candies in this case. Yeah, let's move to the second one. Here the n is 10 and x is 100. In this case chef needs to buy 0, in this case 2 packets. Okay, let's move to the third one. Here n is equals to 10 and x is 9. So in this case remaining equal to 1. Chef needs to buy only 1 candy, but each packet consists of minimum number of candies is 4. Packet doesn't come with 1 candy, so chef have to buy 1 packet. In this case answer is 1. So how will you determine this? Basically find remaining and check if remaining modulo 4, which is remaining is multiple of 4. Answer, yeah, if remaining is multiple of 4, your answer will be remaining by 4. Otherwise your answer will be remaining by 4 plus 1. Hope you guys understand this. In this case, in the third case, remaining is equals to 1. If we check 1 modulo 4, this is not equals to 1. In this case our answer will be remaining 1 by 4 plus 1. So if I divide 1 by 4, our answer will be 0, and 0 plus 1, which is 1. In the second case, remaining is equals to 20 minus 9, which is 11, and 11 is not multiple of 4, so answer will be 11 by 4 plus 1, which is 3 packets. In this case our answer will be 3 packets, so our answer will be 2, 0, 1 and 3. Yeah, 2, 0, 1 and 3, and this is the explanation. Hope you guys understand this. Let's begin the next problem, which is slow solution. And the statement is saying that chef is trying to solve a problem having 3 test cases, where for each test case he is given a single integer n. Chef has an algorithm which takes exactly n square iteration. The time complexity is n squared for a test case with value n, and here are the time constraints. The time constraints are t ranges from 1 to max t, n ranges from 1 to max n, and sum of n over all the test case doesn't exist. This value sum n. Okay, and here are the given values max t, max n and sum n. We have to determine the maximum number of iterations chef algorithm can take for any valid input file satisfying all the constraints which are mentioned here. Formally speaking, we have to find the maximum value of n1 square plus n2 square up to n square t. For this is basically the range which t lies from 1 to max t and ni lies from 1 to max n, and this is the n1 up to nt doesn't exist value of sum n, and this is the input format. T is number of test cases, and each case consists of 3 integers, max t, max n and sum n, which is maximum number of test cases, maximum value of n, and the sum of n over all the test cases doesn't exist the value of sum n. And we have to output the maximum number of iterations chef algorithm can take invalid file size, and this is the constraints of this problem. Okay, let's copy the input. Yeah, okay, let's take the first case, which is max t, max in, sum in. Okay, this is max t, max in, sum in. In the first case, the max t is equals to 10, which is total number of test case is 10, maximum value of n is 100, and sum is 200. Okay, so let's make a variable. Let's make answer. Initially our answer is 0 because 0 iterations. So what will be your approach? We have the maximum test case 10. So if I choose n maximum value, which is 100, the number of iterations will be 100 into 100. Okay, and also make a variable sum. Yeah, initially sum is 0, but after one case, the test case is after the first case, iteration will be 100 into 100, which is this value, and after one case the sum will be 100 because I choose value of n, which is 100, and maximum sum is 200, so I can still add one more n. So if I choose the next value, also maximum value of n, which is 100, and this is the second case, the iteration will also add up to, yeah, the iteration will be 20,000, and sum will become 200 because this is n, this is n. After two test cases, the sum will add up to n, and I cannot run the third case because the sum value will exceed the maximum sum. So in this case our answer will be 20,000. You can also see that. Yeah, let's take the third case. Okay, this is answer. Initially it is 0, and this is sum, it is also initially 0. Okay, so if I choose the value of n, max t is 1000, n is 1000 max n, and max sum is 2200. Okay, so in the first test case t is equal to 1. If I choose the value of n as 1000, so my sum will become 1000, and iteration will become 1000 into 1000, which is 1. Okay, so my sum is 1000. I can choose once, and I can also choose n one more time for test case 2. So the iteration will become n square because the complexity in n square. The answer will add up to this value. Okay, and after two test cases, the sum of n will also become 2000, which is 1000 plus 1000, 2000, and the maximum value of sum can become 2200, but we have reached the 2000, so I cannot choose the, in the third case I cannot choose the maximum value of n, which is 1000. So I can choose only 200 because the remaining value is 200 and I have reached 2000, so I can choose 200. So the iteration will come 200 into 200, which is 400 40. So your maximum iteration will become this will be your answer. And after the third case your sum will become 2200, and further you will not be able to run any test case in this case. So this is a dry run. Let's take the algorithm approach. Okay, so how will I come to the solution? Let's take a look. Okay, first make the sum variable and initialize it with 0. Again answer, it is also in the beginning 0, and run the loop till t, max t, maximum of test case, while max t not 0 and max sum is not equals to 0. Run the loop and check if your sum, this is your sum, if max sum is greater than or equals to sum, you can definitely choose the value of the max n. Your answer will become max n into max n, and your max sum will change up to max n and also t minus minus. Okay, and if this situation fails, which means your max sum is this is max n, this is max n, okay. Here we see in the third case. In the third case we have chosen the 200 but the max n value is 1000, because we have reached the 2000 and the remaining value of the max sum is 200, so we will choose the 200 in this case. Okay, in this situation this condition fail, the max sum is less than max n value, we will choose answer plus equals to max sum into max sum, and max sum will become 0 and also t minus minus, and finally print answer. Okay, let's dry run this on the third case. Okay, dry run this algorithm on the third case. Initially the value of the max t is 1000 and the max n is 1000 and the maximum is 2200. Okay, in the first case max t is not equal to 0, true, and maximum is not equal to 0, also true, and the maximum is 2200 is less than 2200 is greater than or equals to max n, true. Then answer will become maximum into max n which is 1000 into 1000 squared, and maximum will become maximum minus max n. In this case this will become 1200. Don't see this will become 1200, and the loop repeat itself. The test case will become is also not equal to 0, and maximum will become 1200 which is not equal to 0, and 1200 is greater than equals to 1000, true. Answer will becomes 1000, also 1000 square plus 1000 square, and t will decrease by 1 and maximum will decrease by n. In this case 1200 minus 1000 will become 200, and after repeating t is not equal to 0 and maximum is also not equal to 0, maximum is 200, and this situation fails because maximum is 200 which is less than 1000. In this case the code will run this. Answer will become maximum into maximum. The value of maximum is here 200 which is plus 200 squared, and maximum will become 0. And also if I run again, this is not 0, true, 1, and maximum is not equal to 0 but this is 0, this will become false, and the loop will terminate and you will print the sum of all this value which is answer. Hope you guys also understand this. Let's move to the next one, which is journey of the knight, and the statement is saying that chef has an 18-8 chessboard. He placed the knight on the square x1 y1. Note that the square at the intersection of the ith row and jth column is noted by ij, and chef wants to determine whether the knight can end up at the square x2 y2 in the exactly 100 moves or not. And this is the 2 points saying that how the knight moves, and the input format is number of test cases, and in each case consists of 4 integers x1 y1, initial position of the knight, x2 y2, final position of the knight, and we have to determine after 100 move will knight be able to stabilize at this position, will knight stand at this position after exactly 100 number of moves. If yes, we will print yes, otherwise print no. Okay, this is the chessboard. Yeah, this is the chessboard. Initially knight is at 1-1, which is initially knight is at this position. This is knight is at this position, and we have to determine if knight will, after 100 move, knight will stand at 1-1, which is exactly this position. So knight can move this move, knight can choose this path, or knight can choose this path. Here are the 2 possible moves knight can choose. So in the first move, knight will come to here, second, third, fourth, fifth, sixth, and after observing you will find that after even number of move, knight will stand at this position. So 100 is even number, so after 100 moves knight will stand at this position. So in this case you will print yes, and the second case is 8-8 and 7-6. 8-8. This is the 8-8, and the 7-6 is 7 1 2 3 4 5 6 7 6. No, this is 7 6. Yeah, this is 7 6. We have to determine whether knight will be at this position after exactly 100 moves. So what will knight do? Knight will come to this place, and knight can come to this place. Knight will come to this place, but he cannot reach at 7 6. This is not 7 6. Initially knight is at 8 8 8 8. Oh, sorry. Initially knight is at 8 8 and 7 6. It is 7 6. Yeah, we have to determine whether knight will be at 7 6 after exactly 100 number of moves. So in the after first move, knight will come to this place. This is the final destination. Knight will have to come. Okay, in the after first move, knight will come to this move this way, otherwise knight will be at this place. And 2D is here. Knight will choose either knight will come to here, or knight will be at here, or knight will come to from here to here. But you are seeing that the after even number of moves, knight will not come at this place. So in this case you will print no. And in the third case, 8 8 8 6 8 8. This is 8 8 and 8 6 7 1 2 3 4 5 6. Oh, sorry. Yeah, 8 8 and 8 6 8 8 8 6. Yeah, we have to determine will knight come to 8 6 after exactly 100 number of moves. So after the first move, knight will be at this place or this place, and in the second move knight will either come to this place, and in the third move knight will be at this place. Okay, so after repeating exactly 100 number of moves, knight will be at 8 6. In this case you will print yes. So after observation you will see that after observation you will find a solution that check that if x1 and y1 are even or odd. If these two values are, if the difference between these two, which is 8 minus 8, is 0, this is even, and the difference between these two is odd. If both are even or both are odd, you will print yes, otherwise you will print no. In the third case, these two values are, this is called the parity check. These two are even and 8 minus 6, which is also even. In this case you will print yes, no, 1 minus 1 and 1 minus 1 is 0 0, which is even. In this case you will print yes. This is observation based question. And the next one is game of piles version 1. So there are n piles where the ith pile consists of ai stones. Chef and Chefin are playing a game taking alternate turn with Chef starting first. in his turn, safe player can choose any non-empty pile and remove exactly one stone from it. The game ends where exactly one pile becomes empty and the player who made the last move wins. And the statement is saying that T test cases and each case consists of A1 up to AN. AN integers, which is the number of stones in a ith pile. First pile consists AI stones, second A2, and so on. Let's copy the input. Yeah. In the first case, there are two piles consisting of 2 stones each. So, if the safe plays first, safe will remove the first stone from the pile and the first pile will become this and second pile look like this. And the Safina, in the second move is of Safina remove this stone and this will become 0, and in this case Safina will win. And in the 2 to 1 10, yeah, in the third case you will check that safe will remove this Safina, safe, Safina, safe, Safina, safe, Safina, safe, and Safina. In this case also Safina remove the last one. In this case also Safina will win the game. Okay, let's check the third case, which is 1, 5 and 6. In this case the first pile consists of only one stone. In this case safe will remove the first stones and safe will win the game. So from these two cases you will see that if there are even number of even and odd, if even number of stones and player who choose the even number of stones in the pile first lose the game. Safe choose the even number of pile and lose the game. Safe choose the even number of pile and lose the game. So to win the game, the player will choose the odd number of pile if available. The first move will become player will always choose the odd number of pile if available. Let's take an array which is number of piles 1 2 3 4 5. This consists of 5 elements and the elements are 2 3 4 7 and let's say 9. Okay, so in this case the first move is always of safe. It is mentioned in the question. Safe will choose this pile, safe, and then Safina will choose, and the array will become, after the first move array will become 2 after removing the second stone, 2 4 7 and 9. The Safina will always choose the odd pile. Safina will choose, let's say, this pile S. Let's note Safina by SF, and after choosing the Safina the pile will become 2 2 4, 1 stone removed, 6 and 9, and here the only one is, this is the only odd. Safe will choose this pile, and after the safe the pile will become and 8, and the move is of Safina's move. If Safina can choose any number of pile, any pile, she will always lose the game. If Safina choose this one, this will become 1, and in the next move safe will remove this and the pile become empty, and this, in this case safe win. So if you count the number of odd elements, this is odd, this is odd, and this is odd. So odd elements are 3 odds. So you will always look for number of odd elements. So count odds in array and if there are odd number of odd elements, print safe, otherwise print safina. And before checking this, also check that if minimum element in array is 1, print safe, and then continue to the next case. No need to do all these operations. If you find that there is only one stone in any number of any file, if there is one stone, no need to check these values. So explaining one more time. First, check if there is one present in the array, which is minimum element, one present in the array. You will print safe and continue to the move to the next case, and otherwise you will find that count the odds in the array. Is it count the total number of odds element in the array and check if number of odd element in the array is also odd, then print safe, otherwise print safina. So hope you guys understand this. If you like this video, please subscribe to this channel and also like this video. If you find this content helpful, like this video, and see you in next video. See you next time. So thanks for watching. Please subscribe to this channel.